AI agents forgets for two reasons. One, they do not store conversational state, and two, they do not store the user preferences. We'll solve these both by implementing short-term and long-term memory in our AI agent. Let's get to it. So here's the notebook that we'll explore today, and we're looking into memory in AI agents. We will be going into the practicals of short-term and long-term memory. The short-term memory, as it says, it remembers the conversation history, and the long-term memory is to store like information like user preferences, facts, and other things. So we'll just dive right in. So this is the LangChain version that I'm using. So nothing crazy there. So we'll learn the short-term memory first. Short-term memory lets your agent remembers the previous messages in the conversation history so that when you're chatting with like, let's say ChatGPT, it remembers what you've sent earlier. Let me walk you through with that example. So I have a very basic agent. You're an helpful assistant, nothing crazy there. You run it, you create an agent. It has no memory, nothing. You send the first message to the agent. You're saying, okay, my name is John. And it says, hello, John. How can I assist you today? Normal. Then I say, what is my name? And I query it. And it says, I'm sorry, but I don't have access to personal data. Basically, it does not even remember who we are, like within a message. So this is happening because it doesn't have any memory. Every new message to ChatGPT or the agent, it's going as individual message, so it does not remember anything. So we fixed this using short-term memory to the agent, which is done by implementing checkpointer. So checkpointer, the way we import is from langgraph.checkpoint.memory, and we can say in-memory saver. So the reason this is in-memory is just for the demo purpose. In-memory means it will store the history in the RAM. But let's say if you want to do a production system, then you will have to use a database. Right now, it will just store in memory. I'll talk about it later, but let's go ahead from there. And then now what we're saying is in the same create agent, we are saying check pointer, please use in memory saver. So this will enable the short-term memory for the agent. So let's try it out. Now we initialize the agent. So let's see what we are doing here. So in this config, we are creating a unique thread, which will be a UID4. And the first message what we're sending is agent with memory. We're saying my name is John, okay? And just printing the message, the same thing like above. And the second message is what is my name? So this time, what it should do, it should remember the name John. So let's run this. Nice to meet you, John. How can I assist you today? That was the first one. And the second is your name is John. How can I assist you today? So basically it remembered the name, and how it did was it stored the information in the in-memory saver for the thread ID this. So basically for a thread, it's storing the information for each thread. So, and that's how it remembers the information. So the next thing I want to show is, let's say we have two different threads. So how does that work? So I'll explain that using a different thread ID. So what we have here is we are creating two different threads. One thread is for John and the other thread is for Sarah. So in the John thread, we have just made thread ID John thread just for simplicity. And for Sarah, it's Sarah thread. And in the John thread, we are going to send a message to the agent saying, I'm John and I love pizza. And in Sarah, I'm going to say, I'm Sarah and I love sushi. So now we are passing these threads, the configuration to the threads individually. Now, if we query the agent, what it should be doing is it should remember John and Sarah separately in different threads. So let's run this and I'll show you in practical. So it's running. So if you see first, so now we are sending the second message to the agent with using John config again. And I'm asking what's my name and favorite food. And another one is with Sarah config, and we are saying what's my name and favorite food. So now when we ran it, it's printed like my name is John and favorite food is pizza, and for Sarah the same thing respectively. So what this tells us is LangChain and LangGraph is able to isolate both the threads and store the memory and the preferences individually for each thread. So now what we can do is, like, when I'm having a conversation with my agent and you are having a conversation with your agent, they're not going to intermix. Like, my preferences will not go to you, your will not go to mine. So it keeps the isolation, and that's what LangChain and LangGraph is helping us with. So this was short-term memory, and that's how the conversation threads are remembered. Pretty simple, right? Straightforward. So now let's talk about long-term memory. So long-term memory, as you said, it stores the user information, preferences, facts, or whatever we want to store separately. So the short-term memory was for conversation thread isolation. The long-term memory is for actually storing the preferences of the user. So the way Langgraph and LangChain do that is using the in-memory store, but this is again for demo purposes. In production, again, you'll use a database and they have connectors to database as well. But for simplicity, we'll use the in-memory store here again. So the way this works is the in-memory store organizes the memory using a namespace and a key. And the namespace is basically a tuple that groups the related memories together. And a key is the unique identifier for each memory within that tuple, the namespace. So let's walk it through. So we initialize a user ID called, let's say, user123, and then we are doing a memory store dot put, which means we are adding data to the memory store, and we are saying namespace would be users. This is the user ID, and I'm storing preferences, and my preferences would be the key is food. So I'm storing food preferences for this user in this namespace, and the value is preference would be either vegetarian or a favorite cuisine, Italian. So these are the preferences for user ID 123. And then we're storing another preference for the same user, which is about communication. Like, how do you communicate? So this user also, we can say it likes casual style of conversations and in English language. So we're storing these two preferences for this user in memory. And now let's see what, like how to fetch it back. So we'll just run this. So we're saying from memory store, from the namespace user ID preferences, give me what are the food preferences for this user. So it's printing it's vegetarian and Italian, which is the cuisine. So if we had multiple users, so we can just use different user IDs and keep changing it. So it'll store the preferences with a key in a different user. So that's how the preferences per user per category is stored in the in-memory store. Now we can also search like all preferences, like give me all preferences for this user. I'll just run this and we get all preferences, and then we're just iterating over it. And for each item, we say the for food, it's this, for communication, it's this. So now this information we can send it to the LLM, and now with each thread, like each conversation, LLM will be aware of the user preferences and it will reply the same. Let's see that in action. Let's build an agent using the long-term memory. So the same stuff, like we've imported the tool and the in-memory store, initialize the store here. So our tools, we have 4 tools defined here. So one tool is save user preferences. Second would be the get user preferences. Third is the save user fact, and the next would be get user fact. So we are just creating put and get for both ones. So this is our agent, how we initialized it. And we are saying, okay, use this model, and here are the tools to be used. So what we're saying is this agent is now able to save user preferences, get user preferences, save the user facts, and get the user facts. And we are doing some prompt engineering here. We are saying when users share personal information, preferences, or facts, use these tools to store that information. And when the agent should respond to the users, we are instructing it to get the stored preferences and facts and personalize the response before sending it back to the user. And we are also saying always use the current user's user ID for the conversation. So we are prompting the agent to use these tools to save and retrieve user preferences, and this will impact the style and the information that it has, the context it has for that conversation. So let's initialize this. So this is initialized, the agent is ready to go. So now we are saying we're creating the first session in the thread first. What we're saying is, hi, I'm vegetarian, I prefer usual conversation, I work as a data scientist. So this is new person, totally new person, creating a new chat with your agent, and we're just sending it. So now what the agent should do, it should extract these information, use our tools, and store the information in the in-memory store. So now it says, yeah, got it, you're a vegetarian, and it extracted all this information and just normal response. Now in a brand new session, please note this. Here the thread ID was session 1. Now it's a new thread, completely new thread. Now we are saying, can you recommend a restaurant for me? And this is we are sending the new config. So now if I run this, it's running. So now you see it's able to look up that the person was vegetarian and what the preferences was. So it's replying with the context of that. So now it's saying, I know you're a vegetarian, so there's a green leaf bistro restaurant and blah blah blah. So see how the magic happens. Now it can know about the user. It can reply according to the user. And that's how ChatGPT and OpenAI and Anthropic and all these guys are doing. Like they're storing all your chat history and conversations, and then responding the way you like it. If you're an engineer, they're responding you as an engineer. So more technical. If you are let's say a creator, it's gonna reply you as a creator. So that's amazing. So let's see like what actually was stored. Now what we'll do is we use the agent to query and all, but let's see what it actually stored in the memory. So what we're saying is in store.search, give me all the current user preferences, and what it's the communication style is casual. So it stored that. It also storing the date. That's pretty awesome. And then food was vegetarian, and the facts that it stored about the user in the facts namespace that it works as a data scientist. So this is amazing, right? Like it's able to store multiple facts and multiple preferences and then reply accordingly. So this is awesome. So just to summarize, just to summarize again, the short-term memory is for thread isolation, so that you can store conversation history and you have a context. And the long-term memory is for actually storing the user preferences and the facts about the user. So yeah, this was it, and I hope you liked the video. If you want to learn anything else, please comment on the video as well. And I think this is super useful to make your user experience of your agent brilliant and very personalized. You can now use these memories and these concepts in your agents and really create something useful for you and for others and people around you. If you want to learn any new concept, like I said, please let me know in the comments and I will deep dive and create a video out of it. Until then, thank you so much and keep learning.